Good day everyone, I am Anatim Vulani. I am an Innovation Resource Officer at the Force Discovery Center, University of Fort Hare. I'm with my colleague, Mr. Indipile Ngambuza. Today we'll take you through our science, technology, and engineering exhibits. This exhibit is called the energy converter. In this energy converter, we have two magnets on both sides. And in between the magnet, we have what you call a magnetic field. And then we have the coils. This exhibit uses the principle of induction, whereby electric current is created whenever a conductor is moved in a magnetic field. So by rotating the wheel containing the lights, you are actually moving a conductor in a magnetic field. That is why we will see the wheel lightning when rotated. Therefore, by rotating the wheel, you are actually applying a mechanical energy that will be converted into an electrical energy. This exhibit is called the viscosity cubes. It contains 4 cubes. In these cubes, we have a syrup, we have a water, we have oil, and we have a shampoo. By definition, the viscosity is the resistance of the flow of an object in a fluid. So the viscosity of each cube is unique. It depends upon the strength of the intermolecular forces. So the stronger the intermolecular force, the more viscous the fluid, meaning the more difficult for the maple ball to flow. So if you flip over the cubes, you will find that the ball moves with a different speed on each cube. As you can see, the one with water moves faster than the others, and the one with shampoo moves slower than the other. This exhibit is called the power of petal. It uses the principle of Faraday's law of induction, which says a changing magnetic field in a conductor creates an electricity in the conductor. So by rotating the petal, it changes the magnetic field inside the conductor, which then creates the electricity in the conductor. As you can see, when a person rotates a petal, all the appliances inside this power of petal start working up.
Now we'll explore some of the engineering exhibits that are available at Force Discovery Center. The first one is a complete automobile system. It is a system that is made up of several processes that works together to produce kinetic energy at the wheel. Today, I will demonstrate how the power is generated by the engine. The first component is the battery, and its purpose is to provide electric current to the starting motor. Okay, now I will turn on the car to allow electric current to flow to the starter motor. The next step is to switch on the ignition button to start the engine. The engine has started. Now let's see what happens inside the engine. The moving silver parts in the engine car are called pistons and are usually enclosed in a cylinder. The combustion process occurs inside the cylinder. It is a basic chemical process of releasing energy from a fuel and a mixture of air. All the energy produced by the combustion process is transferred by the piston to the crankshaft. The crankshaft transfers the engine power to the transmission. The purpose of any transmission is to transfer the engine power to a drive shaft and the rear wheels. Gears inside the transmission changes the vehicle's drive wheels speed and in relation to the engine speed. When the engine is running, it also produces electric current, which is used to charge the battery. That electric current is used to power lights, radio, and other electric components of the car.
This exhibit is called induction demonstrator. It shows the principle that says a current carrying conductor has magnetic field around it. So whenever you press the green button, the magnetic ring is lifted up. This is due to the repulsion of the conductor's magnetic field and the magnetic field of the magnetic ring. So when you press the green button, you can see that the magnetic ring is being lifted up. The significance of science exhibits is to develop the scientific spirit and curiosity to students, and also to trigger students to follow careers in science. The aim of our science exhibit is to explore the creative talent and innovative skills of students, and also to trigger their mindset to think outside the box, so that in future we can have youth who are more creative and more innovative, so that they can become job creators rather than being job seekers. I thank you.